Well, good afternoon, everyone. Thank you for coming out for a midday lecture. My name is John Mann, Director of Education for Lakeside, and this session is on climate and will explore the dramatically different weather and climates in Alaska and Hawaii. We're fortunate to welcome Ross Ellett back to Lakeside. Ross is currently part of Toledo's 13 ABC weather team, where he serves as the weekday morning meteorologist. Ross has personally experienced a variety of different weather settings and challenges in his career and holds the Certified Broadcast Meteorologist designation, the highest professional certification awarded by the American Meteorologists Society. And this afternoon, Ross will explore some of the most impactful weather events of Alaska and Hawaii. For tomorrow morning, Chef Stacy Maple will be here, and she'll be cooking the different flavors of Alaska and Hawaii for our theme week. I do ask if you would please turn off your cell phone ringers if you haven't already, and please help me in welcoming Ross Ellett.
Thank you, and thank you for taking a break from enjoying the nice weather outside and coming in here. But we're going to talk about Alaska and Hawaii climate, and I picked out a variety of extreme events here, and very, very interesting thing, a great variety. I mean, we're talking about Hawaii, which already that state has one of the most diverse climate systems in it of any state in the country, and it's one of the smaller ones. I mean, California has a lot of different climates, very diverse, but Hawaii is even smaller than that. And then, of course, you throw in Alaska, the largest state, and there's all kinds of things going on through there. How many of you guys have been to either Alaska or Hawaii in here? Okay. How many just to Hawaii? All right, what about Alaska? Okay, all right. So I'm excited to talk about this today, and I had a lot of fun putting this presentation together and going through some of this. And one of the weather events I'm going to talk about in Alaska, we were there for. So I'll reflect on the storm and the historic impact of it, but then also kind of our personal experience as we're going through it as well. So I'll start off here by looking at Hawaii. We'll just kind of start off overlooking the climate altogether. And so you have a lot of different varieties, subclimates, and all of that across the entire world that are classified. But when we're looking at the overall landscape here, generally you've got like 5 different basic climate types. So you've got one for kind of where we're at here and more of a temperate setup and so forth. But then when you look at Hawaii, the elevation is everything. And so for most folks that visit Hawaii, you're kind of on the outer edges. You're near a beach, and of course you got the different islands. The big island there is by far the most diverse. It has the largest elevation height there, and right in the middle you've got Mauna Kea and Mauna Loa there, so you have very high elevations. And it's pretty remarkable to go from sea level and really not that far away when you think about it. All of a sudden the elevation's climbing to 10,000, 11,000. Mauna Kea is, I believe, a little over 14,000 feet. And so you get really high up there, and it's remarkable. It's cold, even in the summertime. And so it snows there, and in fact, they don't get quite as much snow as what we get, but then in recent years, I guess it's been probably maybe a little more comparable because we haven't had as much snow, and they've actually had a little more. So it's very interesting how things can change, and of course, the elevation's everything. You have the breeze there. Generally, the weather is moving from east to west across Hawaii, or almost kind of from the east-northeast, kind of moving across to the west to southwest. And so that really drives the climate. So you've got the ocean and you got the elevation. And if you are on kind of the east side of those higher elevations, you pick up on a lot of rain. It's more of a tropical environment. And if you're on the other side of it, it can be very arid and almost desert-like. And so for the Big Island, if you are flying in on the west side of the island altogether, it's very dry. It's a much different climate than if you're on to the east side of it. And then of course you've got Volcanoes National Park, or Hawaii Volcanoes National Park. That's kind of on the edge of some of those wetter environments as well. And then as you go to the other islands, it's basically kind of a smaller version of the Big Island there. But we'll also talk a lot about Kauai and one of the bigger setups there altogether. So this is a look at the wind pattern here. Kind of the general wind pattern is you have those winds, again, generally going from east to west. So they kind of drift off to the southwest there just a little bit. And then if we look kind of at the different times of the day and how those winds will impact just the Big Island, of course, you've got the different elevations there, but then also when you have night, if you have conditions that will change a little bit too. We're familiar here with the lake breeze that will be present all the time. Sometimes the winds are coming from the lake. If you get a stronger southwest wind, it'll push that boundary out over the lake. You still have that boundary at play when you've got the Big Island there right around the ocean, but then again, you've got the mountains that are impacting the wind streams altogether. And so if we just look at the Big Island in general and look at the different rainfall patterns there all together, it's just remarkable. And for you guys that have been out there and have drove around the Big Island, or really any of the islands in particular, but the Big Island is most drastic, is that you're driving along and then all of a sudden you kind of get on the other side of the mountain range or the mountains themselves, and everything can look different, everything can change. I remember for us, we flew into Kona, we drove basically over to the other side of the island. We're closer to Volcanoes National Park. And again, you're kind of twisting and turning and taking in all the sights and the views, and the elevation's going up, 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 and then all of a sudden you just kind of see this deck of clouds extending, and then you drive down into the clouds, and all of a sudden it's a tropical environment, it's raining, it's gray, we hardly saw the sun. Except for at night, you kind of had the conditions there where the sky would clear, but then they would cloud back up in the day. But on the other side of the island, they hardly get any rain at all. I mean, if you look just north of Kona, they're getting less than 10 inches of rain per year. So we think of Hawaii as this tropical environment, and some parts of the islands are, for sure. You look at the other side of the island, and you're talking as much as 200 inches of rain a year. I mean, some of the wettest spots in the country are not far away from some of the driest spots that we have in the U.S., and it's all on this one island. So this is a really remarkable setup, just looking at a very confined area and how many different climates there are just on this one island alone. All right, so if we look at Kona versus the other side of the island here, you can see the different precipitation. And this scale is kind of goofy because when you first look at it, it almost kind of looks the same. But then when you look at the scale over on the right here, you can see the precipitation. And for Hilo, you've got 4 inches, 8 inches, 12 inches, 16 inches. That's your scale. And then on the other one at the top of the scale, it's only 2.8 inches of rain. And so then now you look at the different months of the year. And so the rainy season's more or less the same. As you go into the winter and early spring, it's much wetter there. In the summertime, it's much drier. But you can see how drastically different it is. And then for the drier climate in Kona, you can see the temperatures there. They're pushing like 85, 88 for an average high, kind of like what we'd have here, I guess, in the middle of the summer, even a little closer to 90 degrees. But then it's going to drop lower at night because you have less humidity and you don't have as much of a range there. Meanwhile, on the other side of the island, it's just like consistently like 75, it seems like all the time. It just doesn't move a whole lot. Because you just have high amounts of moisture. So again, a totally different climate system depending on where you're at on the island. And then if you go up in elevation, and it's hard to find spots clear at the top there of the, like Mauna Kea, for example. I couldn't find some real good data to share, but this is Mauna Loa, which is the other really high location. And it's pretty far up there, but you can see the temperatures are much colder, so the average high through the year is more like in the 50s, and they do get down into the upper 30s pretty routinely, and then you get, if you get a slight cold snap there, you're going to get even colder. And then you can see the rain amounts through the year, again, are also quite low at that location. So it's more of a drier climate, and it's also up much higher, and it's obviously much colder as a result. All right, so that's an overview of Hawaii. Now we go to Alaska, and it's obviously much different, much colder. And of course, Alaska is diverse. It's a large state. There's so much diversity in Alaska, and personally, it's my favorite state because of that. There's just so much to explore. It's such a wild area. But with that said, it's not, if you look at Hawaii's got all of these climates jam-packed in a really small area. Alaska, it's more spread out, and the continental climate, basically subarctic climate, is present a lot. But then you get down into the Aleutian Islands, you get out towards the higher elevations there up against British Columbia and Canada, and you're more of a temperate environment. And so you think like Anchorage, for example, Anchorage is located right down in here. So you've got these big mountains that kind of come up like that. This is the Alaska Range right in here. So that's going to block a lot of moisture. Then you got the Brooks Range up in here. So for Anchorage, you're still down in here. You get a lot of moisture that will come up off the Gulf of Alaska. And so really, they're like a colder Seattle is a good way of explaining their climate there in Anchorage. So it's, again, more of a moderate climate because of the ocean there. They definitely get frequent rain. They get the snow. That adds up. But then you get north of the Alaska Range, and that blocks a lot of moisture. Of course, here's the Arctic Ocean to the north. That's Brooks Range is going to block a lot of that. So when you're in the middle, this is the interior of Alaska, and Fairbanks is situated in there, for example. And it's a much drier climate that they've got there. But these temperature extremes are all over the place here. So when it comes to the continental climate, they bring the most extreme temperature swings of any of the climates that we have out there. And so it definitely makes for some really interesting weather, no doubt about it. All right, so here's a look at Alaska, and I kind of pointed out some of these ranges already. Brooks Range up here, Alaska Range, and then you have these high elevations from the Aleutian Islands back down. And you can kind of see how in January, kind of the average wind speed would be and how it changes a little bit as you go into July. But still, in the middle of Alaska, you've got a lot of land, and it's blocking a lot of the ocean there altogether. But meanwhile, it's frequently, you've got clouds and rain that's kind of hanging around there right towards the southern part. When it comes to snowfall, some of the most insane snow totals anywhere. I mean, you can think of spots into the Sierra Nevada and California, for example, and then even Washington and Oregon, some of those peaks have got a lot of snow. But you get right into some of these areas here, and I mean, those high elevations, and you're just pumping in moisture from the Gulf of Alaska. I mean, they're picking up on hundreds and hundreds of inches of snow a year. Meanwhile, you get to an area like Fairbanks, and you might be surprised, they're so cold, it can snow easily from October all the way into May, and they get about 60 inches of snow a year. So for Fairbanks, Alaska, I mean, yeah, it's a lot of snow, but then you figure that's a drier, more of a fluffy snow, not as much moisture content in it. And it's so spread out through the year that it's really not all that impressive compared to like what we would have around here. If we get, say, 36 inches of snow, and you start thinking that, all right, realistically, yeah, we may get some flurries in October and maybe an inch of snow in November, but really it's coming like late December, January, February, maybe into March. If you kind of spread that out, we're actually getting kind of a heavier snow content when we get our snow here than what they're getting there. And it's just because a lot of that's being blocked. So this is a look at Fairbanks, Alaska at the top here. And then you have Anchorage that is down here. And again, you got to look at the scale with those temperatures there, especially on the negative side there when it comes to that scale for Fairbanks. And so January, those temperatures are dropping down. I believe their average high right now is like minus 0.2 degrees or something like that in January. So basically zero, and the average low is right around about 20 below roughly for January. But they can have massive swings. And so it's not uncommon for December and January in Fairbanks, Alaska, for the temperature to be freezing, 35 degrees. And that is a lot of warmth for them. Now, when that's happening, it's generally snowing and it's cloudy and so forth. But then the temperature can fall easily to 30, 40, 50 below. This can happen over the course of 7, 10 days, 2 weeks. It's just such a dry climate. You can have these massive temperature swings there. You don't get that as much in Anchorage, but you do get more moisture. So the precipitation there per month, you can see basically the cloudy, rainy season of Fairbanks will go into the fall and very beginning of winter, and then it really drops off. Similar situation for Anchorage. You can see how it really drops off in the summertime. They actually have really pleasant weather there in the summer, but they get a lot of precipitation when it comes to snowfall. Snowfall is this lighter blue, and then the darker blue here is the rainfall precipitation that they get. But you can kind of see December, Anchorage is getting a lot more snow than Fairbanks typically, for example, as they get all that moisture to come in. And then for Juneau, Alaska, so if you think kind of back down a little farther south and east, they're getting, it's even more of an influence of all that moisture there. So the temperatures are very moderate. The average high doesn't really go above 60 even in the summer. But then look at the average high here in the wintertime. It's kind of like us, really. I mean, you're talking 30s. And the temperature there for the lows are dropping down into the 20s. And so that's actually a little warmer than what we have here. So it really is a moderate climate because of all that moisture that they have there. and they do get some big storms. And Juneau, by the way, that was one spot I thought about putting in this presentation from this year. If you remember some of the headlines, they did these massive amounts of snow coming in with storm after storm after storm. It was like collapsing roofs and all of that. So that was one that I considered throwing in there. I'm going to start off, though, by looking back into the 1970s. We had our fair share of cold blasts here in the 1970s. And Canada and North America had an outstanding one, or one that's pretty much at the top of the record books that I'm going to talk about. And so January 1971, it was a La Nina year. It was very similar to what we just came out of. And so generally, they've got colder than average weather there up into most of Alaska. That will come down into parts of the United States. And for us, usually we've got kind of a wetter setup as we go into the winter. But the winter of 1970-71, it was a moderate La Nina, and that pattern brings that blocking area of high pressure, and typically for them it's colder than normal temperatures, but that's on average, and things can shift quite a bit. And so as we look at that cold wave that they had, again, here's your typical La Nina pattern, and then you look at what was going on. This is kind of where the bulk of this cold air, where that trough was situated, and then here's the temperature patterns there across the North America altogether there in January 1971. And so it really does mimic, if you look at this setup, and again, that jet stream would come down very similar to a La Nina. It was kind of a classic setup. You do see some missing data across parts of Alaska here just because of a lack of data that was there, but it was the bullseye for all of that cold air. So I'm going to take you to Fairbanks, interior Alaska, and it really was all of interior Alaska that dealt with this cold. But this was definitely an extreme of all extremes here. For Fairbanks, Alaska, they had 18 days in a row with lows between 40 and 60 below zero. And 10 days there with lows between 55 and 60 below. So it's getting down to 30 to 40 below. That's kind of like a normal cold snap for the winter. This is not normal for them. Highs there is cold. Highs as cold as 54 below. You can imagine that, just hardly any change there at all. And so I've pulled up the temperature records here. This is again for Fairbanks, Alaska. I mean, it was sunny. There wasn't a whole lot of precipitation there, but yeah, this is a look at the low temperatures. There's your 60 below, a high of 28 below, high of 54 below, and a low there of 59 below zero. Fairbanks was not the coldest spot that was in that area. It was the biggest city that was in that spot there. Fairbanks actually had some other issues too. They had days of dense ice fog. Now, ice fog is not freezing fog. So we got a whole nother level of fog that most people aren't even aware of because you got to have extremely cold air to get it. When you have freezing fog, you have supercooled water droplets that are in the air, and they basically immediately are clinging. That moisture is going to cling to the trees or elevated objects, whatever's around them, and it's going to create that layer of ice, rime ice that will grow. It's really pretty. If you get it on the trees after some freezing fog, the sun comes out, I mean, it is some of the most beautiful winter landscapes that I think you can imagine. Now, if the temperature drops cold enough, you can go, you have to get it really, really cold for you to have suspended ice particles in the air versus suspended supercooled water droplets. It's kind of interesting, really. I'm not going to dive off into the physics of it or why it all works, but it is really interesting on why it can be so cold and yet you actually still have suspended supercooled water droplets that are there. But if you get it cold enough, especially if you start getting it down around 30, 40 below, especially if you're at that level, that moisture no longer, it's so cold it doesn't even matter anymore. It's going to be suspended little ice crystals, and this could be a real problem. These are really, really tiny ice particles, and it can be dense fog, and it can really cause havoc to where you can't see very well at all, and they do not like this ice fog there. But there was a 4-car accident in Fairbanks due to that, but basically they got into such a very clear pattern, and Fairbanks is in a valley to where this fog just settled there day after day after day. So they were dealing with that. Meanwhile, when you start to venture out a little bit, so we're going to believe it's range, and then here's Fairbanks with all the weather sensors here. Basically, the Dalton Highway connects them. And if you go up, again, a little farther north on the other side of the Brooks Range there, you had spots, I mean, down to 68 below zero there for the temperature. And so this spot actually recorded a coldest high temperature there on the record books of 66 below zero. That was the high temperature on that particular day. Alaska's record for the coldest high temperature of any day was set with that. And again, just a remarkable, I mean, look how long lasting this is. So right here, I mean, you've got January starting, they've got a little warm up, you get to like 20 degrees, and then you fall. I mean, here's the 25 below line, and you're pretty much below that the entire time. You get to this middle part of the month and beyond, I mean, you're down close to 50 below or lower a lot of that stretch. It's just absolutely remarkable. So they had a cold snap with temperatures of 25 below or colder for the entire month after January 5th. And by the way, this did go a month long. It did extend into February just a little bit before they snapped out of it. And then here's the big one. This was the record that was set. Now, the record for the coldest temperature in North America is 81 below. Canada holds that. The U.S. almost took that down. This was Prospect Creek, and it was a location of a construction camp there that they were doing when they were putting in the Alaska pipeline. And so they were there, they had weather sensors there, and that location dropped 80 below. Now again, here's Fairbanks, here's the Brooks Range. I just showed you another weather sensor right here. So this is, by the way, is the Yukon River that goes through here. So these are really, really cold areas into the winter time in particular. But I mean, this cold snap here was the big one, and there wasn't anything else that was bigger than that. So the coldest U.S. temperature on record was this event. It was 80 below zero, the high 64 below. The Yukon, again, holds that record there for the coldest North American temperature. That was 81.4 degrees below zero for that. And I didn't write the year down on this one. It was like the 20s or the 40s. It was before the 70s. That record has been on the books for a long, long time there. All right, so now I'm going to take you to December of 2021. We had a warm spell that came in, and so this is much more recent. It was right around Christmas going into New Year's, so it's about a month earlier into the year, and this is the one that I was there for in Fairbanks. So we took basically a family vacation, and we decided to fly out on Christmas Day. The plane tickets were much cheaper on that particular day, and so we were like, all right, we'll go ahead and do that. And so our whole idea was we love going to Alaska. We love going and searching for the Northern Lights, and and just kind of having a nice winter trip. And so that's what we were doing. And we went up there, again, flew up there on Christmas Day and stayed there. I think it was going to be like the second or third or in January that we were going to be there for. But this already, as I'm looking at kind of the long-range forecast, I mean, I'm like, there was this battle that was taking place between basically this, it was an atmospheric river, just a pipeline of moisture coming in, and a big area of high pressure. And it was initially, I'm looking at like 10 days, I'm like, all right, I think we're going to be okay. And then every single day, I'm looking at the forecast, and it's like, this looks bad. This looks really bad. And then it was like historic, unprecedented, like everything you could imagine. So like the meteorologist in me was like, this is going to be awesome. And then, the family guy, me wanting to see the Northern Lights, all that other stuff is like, this is going to be an absolute disaster. And so first, before we even went up there, they had a big storm. Now, Fairbanks, again, 60 inches is their average snow for the entire season. And it's a drier climate. And usually when it snows, they get like an inch of snow. It falls, it doesn't melt. It's just hanging out there all winter long. Well, you get 4 or 5 inches. That's a pretty big storm up there, believe it or not. I mean, we think of Alaska, and you're like, oh, they're hardy, they deal with all these big storms. They don't usually. Now, again, there are exceptions to the rule, but you get into the interior of Alaska, there just isn't much moisture. But when you get a bunch of warm air that floods in, that warm air usually comes with a lot of moisture. So before we even got there, they got a big storm, and temperature warmed up just above freezing for the highs, and it dropped a little over 9 inches of snow. There were spots kind of on the outside of Fairbanks that picked up 10, 11 inches of snow with it. So they already going into this, they had a lot of snow on the ground. It was very wintry. And then we get to Christmas, and this was just remarkable all the way around. So again, the average high is 4 degrees, average low there 13 below, kind of during the month of December. Average precipitation for the entire month is a little over 0.6 inches, all right? That is like a third of what we get in the month of December, for example. So that's not much moisture. They get about a foot of snow out of that, but that means that snow ratio is very high, which means it's a very powdery, dry snow. They don't get these heavy, wet snows typically. And so that's, again, the average of what you're typically dealing with. And this particular month, Temperatures were 5 to 10 degrees above normal for the month, so it wasn't significantly above normal, but it was above normal. And it all had to do with these particular storms that came in. But the moisture content was just beyond comprehension. Nearly 6 inches of precipitation fell during the month of December. That's 9 times higher than what they typically get. 9 times higher. By the way, it beat the record, the previous record. They almost doubled it. Just mind-blowing statistics on how much moisture they got. Another way of looking at it, again, is that they got roughly about 9 months worth of precipitation in this one month, and it was all pretty much in the last 10 days of the month was when it all came in. Normal snow is 12 inches. They got about 50 inches of snow in that span there, so more than 4 times what they normally had. So as we're getting ready to board the plane, this was from the National Weather Service, and you're kind of going through it, heavy snow, significant accumulations expected, 10 to 15 inches, up to 20 inches kind of in the hills, which is where we had a cabin. Farther south, 25 inches. But then they start talking about the freezing rain chances that go along with it. And so that continued to increase. So as we got closer, it was looking warmer and there was more moisture. It was just, every time you looked at a computer model, it was like, this doesn't seem like it's even possible. And it was definitely all possible because it all definitely came to fruition. So here's a look at some of the weather maps. Again, here's Alaska, and here's your blocking high pressure. That was hanging around and did influence, and this pipeline of moisture came right over the ocean, came up kind of missing the mountain ranges and going right into basically all of Alaska was impacted by some regard, but basically just pumped that moisture straight in. So not only was it one, but you had multiple storms here. So here's your first storm, but it was connected to this bigger storm that was farther away. And again, this high pressure is situated that it's just pushing this pipeline of moisture around this way, and it's just directing it straight in. So when you hear about the atmospheric river, this was the atmospheric river. It was not down by Hawaii and coming in towards California like this. It was directed really far north and moving into that colder air. This was the weather map that I was looking at on the computer models. High pressure to the south, lower pressure. These isobars are just nuts, which indicates a lot of wind out over the ocean. I think they did have like hurricane force winds with it out this way. We did not in the interior Alaska. A lot of that will get blocked and the winds aren't as bad. But you can just see again that moisture just pumping straight in to the central part of Alaska. These are a look at some of the computer models when it came to the snow. This is for the last 2 storms, so the storms that we were there. Fairbanks situated right here, so you're talking 28, 30 inches. This is closing in on close to 3 feet that it was showing. And then look at some of these higher elevations that were on the edge of the Brooks Range, over 50 inches of snow. They probably got it. I don't know if there was there aren't weather observations in those spots to prove whether that happened or not, but I mean, this was a widespread event. And then this is a look at the ice totals, and here is Fairbanks. And again, right as you're starting to go into right as you're approaching Christmas, I think is when I was looking at. Yeah, so this was Christmas morning. I pulled this up. I think we were at the airport and I'm looking at this. I just couldn't believe it. But showing close to a ½ inch of ice right around Fairbanks, and that actually did happen, and they lost power due to it. So here's the satellite image. Again, here's your pipeline of moisture. Alaska, as we all know, is a massive state. The whole state had something going on with it. This was Fairbanks. These are the hills kind of surrounding it, and this is our location. And I remember, so here's the deal for us. The thought was, okay, we're going to get there. We're probably going to get snowed in. We're not going to be able to move and get out of this situation. So I thought, all right, but I was pretty confident we'd be able to get in. I mean, Fairbanks does deal with snow. They deal with cold. It was light snow to start, so we were pretty confident we'd be able to get into the airport, get to our cabin and so forth. And I thought, we'll just make sure we got to get a bunch of groceries as soon as we get off the plane. And then it hits you. Well, we're coming in on Christmas Day. Nothing's going to be open when we get in there. So last minute, we went to the grocery store in Toledo. We got another bag. We packed 50 pounds of food or whatever it was, weighed that bag, made sure, because it was like, we're going to pay for another bag. We're going to bring this with us. Thank goodness we did that because we would have been in real trouble if not. We had our other plan was, we'll have a grocery order ready to go early in the morning. We'll do a grocery pickup. I think it was Walmart or Fred Meyer's, one of those too. And then we'll go to that. And I don't even think I even got to look out the window before we got a call from them that morning and said, the store's shut down. Like, nobody can get to work. We're sorry, but we can't complete your order. So, You know it's not good when people in Alaska that are used to this stuff, they're like, yeah, we can't even go out there. This is a look at the radar. For you guys that, if you're not familiar, if you get a radar image that has any yellows on it at all during the winter, that's in the form of winter precipitation, it is going to be a bad storm. Let alone oranges or reds. So I was just amazed that I was looking outside, couldn't believe what I was looking at, and then I saw this wall coming towards us on the radar. I'm like, okay, here we go. And it started off as it was snow, it just got heavier and heavier and heavier, and then it was massive snowflakes just raining down, and then it was rain mixing in, it was freezing rain. We were up in elevation just a little bit. We didn't get as much of the freezing rain as what they got down in Fairbanks. We got a little more plain rain, actually, and just a bunch of snow with it. But in Fairbanks themselves, they got enough ice to really cause some problems, and that was enough to actually kind of shut down not only the roads, but the power grid itself. There were a lot of people, I think it was like 17,000 people that lost power. We had power that went out and back in and so forth, but didn't lose it for an extensive period of time. All right, so we ended up deciding, like, there's a gap between the storms, and initially that second storm didn't look as bad, and then each day we're like, this one's looking worse and worse too. I just couldn't believe what we were seeing. So we were totally snowed in for a couple days, and basically it was like, all right, we need to get out, because we're fine for a couple more days on the food, but if we get snowed in again, we're going to run out. I mean, we're going to start to find whatever we can kind of in the cupboards and stuff like that there in the cabin. We finally got dug out. We went on those roads, and I'll tell you, those roads were the worst roads I've ever seen in my life. I mean, again, you're in an Arctic location. These roads are generally very cold. They don't put salt down. They won't do anything there. Basically, they're just kind of grading the road and throwing down some gravel on top of it. And then when you got the rain, even when it was pure rain and not freezing rain, it still was only like 35. The road is super, super cold, and it froze up anyways. There was a solid inch of ice on all of those roads. And so we were barely moving. We got into Fred Meyer. Now imagine right in between Christmas has ended, New Year's is coming, okay? Everyone's typically going to the store and grabbing food and stuff anyways. And now you just had one historic storm of the magnitude that hasn't been recorded there in Fairbanks before. And now the warnings are coming out of another unprecedented storm around the corner. Can you imagine what it was like? And by the way, a lot of people still couldn't get to work. There was one poor cashier that was there. There was no produce. It was completely wiped out. And you know what? That was fine by us. Like, we're just like, anybody that was in there was like, we're just grateful to be here. Let's get the food we need and get out. We got some chains for the rental car, put shovels in the back, all kinds of stuff there. So the second storm began. This was the main road, actually, right by our cabin, which is already pretty impassable. Then it got a lot worse from there. Going into this second storm, this one was all snow, but when I woke up the next morning and looked outside, I couldn't believe it, because for Fairbanks, they don't get a whole lot of wind. That's the great thing about it. It's super cold if you're going there for the aurora, but generally, it's in Fairbanks itself, the winds aren't there. They're in this valley, and so again, there's not a whole lot. It's just cold, but there's not a whole lot of wind. It's a different feel than it is here. Woke up that morning and I look outside, you couldn't see anything. It was a full-fledged blizzard that was out there. So winds there gusting to 44 miles an hour, sustained there at about 30 miles an hour. This was at the airport, and these bands of snow were coming in. The airport shut down for the first time in recorded history in Fairbanks. So think of all the weather that they have to deal with. This is the only time to date that they've actually shut the airport down. It was due to the second storm that came in. So this one dropped another 14 to 15 inches, and it was a blizzard, and the snow depth was over 3 feet, and it was not a fluffy snow anymore because you had all that moisture compacted down there. Now on the back side of this, that Arctic high came in, and you can see the temperature. This was the model projection on Christmas. So we knew at some point, if we were there long enough, that the temperatures were going to fall apart there. And right towards the end of our trip, it did. The temperature dropped to 47 below there for the actual temperature. And that ended up being the coldest temperature they had had there in Fairbanks in 5 years. So we started off at 41 for this trip. And as we were getting ready to leave, it was 47 below zero. So an 88-degree actual temperature swing. There wasn't much wind, but every once in a while, a light breeze. You get a light breeze at 40 below, it immediately pumps the wind chill reading to like 60, 70 below or something along those lines. So that was by far the coldest air that I've ever felt. With that said, it was clear, and we did get to see the northern lights on that last night. I was actually surprised it was as cold as what it was. We're outside kind of watching it, everything else got in the car, and it said 40 below, and I'm like, okay, and sure enough, it was every bit as cold as that. All right, let's move to some warmer weather. We'll move here to Hawaii, and we'll talk about one of really the biggest hurricane to impact Hawaii. Hawaii doesn't get a lot of hurricanes generally. A lot of times they'll kind of track down to the south and will stay away from Hawaii. This one did not. This was in 1991. And this storm took basically you had a big area of high pressure out here, and so that flow around it, that steered that hurricane right up into Kauai. How many of you guys, a lot of people have been to Hawaii. How many have been to Kauai? Okay, so really, really lush island. Did you see all the chickens around? Okay, it's because of the storm. This storm was a monster. It came through, destroyed a bunch of these chicken coops, and since then they've had a major chicken problem, overtaking the island. But this storm came in September 8th, 1991. It was a Category 4 storm. When it came in, it was the costliest hurricane to strike Hawaii, over $3 billion in damage there. It was actually a pretty quick mover across the island. It didn't last all that long, but it did cause 7 deaths, 2 offshore, 3 there in Kauai, and then 2 a little closer to Honolulu, so right in here. And there's about 100 injuries with it as well. But it moved across the island in 40 minutes altogether. Sustained winds around 100 to 120 miles an hour. Wind gusts estimated 175 miles an hour at landfall, and an uncalibrated wind gust there. So again, some uncertainty on exactly how accurate that reading was, but 217 miles per hour on a ridge. Also, there's another report of 143 mile per hour wind gusts. The storm surged 13 to 20 feet, and that was on top, or I guess maybe underneath of the waves. The waves were on top of the storm surge there, and the waves were 17 feet altogether. So that pushed a big wall of water up a lot of the rivers and so forth is where that came in. Of course, Hawaii, you get up in elevation pretty quickly, but this did cause some problems too there in Kauai. So it took a long time to get the power back. 4 weeks after the storm, 20% of the power was restored. And then the months after the storm, many of the insurance companies left Hawaii. It was a big fear there altogether. So this ended up prompting the governor there to take some action again with the Hurricane Relief Fund in 1993 to help protect the unprotected Hawaii residents. The fund was never needed for another Hawaii hurricane, and it was eliminated in 2000 as a bunch of the insurance companies came back and said, okay, maybe it's not as risky to insure folks there as what we thought. But this is a satellite imagery there of the storm when it came in. Again, it took that turn, came up from the south. The eye went basically right through there, putting the worst of the impacts, well, really the whole island, because I mean the thing went pretty much right over the center of it. But with the island, again, I think it takes like an hour to drive around it, but as the crow flies, it's really not that big altogether, and so it went right through it. So it did ravage multiple islands there, but the native bird population definitely took a hit, and so I don't know how to say that particular bird, but it was believed that it led to its extinction there. And the storm, as I mentioned, destroyed a lot of the chicken coops. The chickens got loose, and it's interesting today, they estimate anywhere from 10,000 to 50,000 chickens. The population fluctuates a lot, but they are everywhere. So you go out hiking on those trails, you think you're in the middle of nowhere, and all you hear is just clucking and chickens. It is a fascinating thing. I mean, you go to Walmart, they're going through the parking lot, they're everywhere there, but it all goes back to that storm. I found this really, really fascinating. So I think everyone knows about the Tornado F scale, and that's from Dr. Ted Fujita. And he's one of the most brilliant meteorologists probably that's ever been. We think around here, the Palm Sunday tornado outbreak in 1965, for example. And his work after that, taking a Cessna plane, flying over the area and doing extremely detailed analysis from what he did, from the photographs. He took 7 different flights over all these damage paths and put together a study that basically has never been done to that extent before. It literally changed how we are able to forecast tornadoes. It changed the warning system. Virtually wasn't much of anything back in 1965. It changed all that. Just a groundbreaking research that this guy has done in his career. Well, he also decided after the storm went through in the 90s that he wanted to take a look and investigate the wind patterns with it. And then we're left with this amazing detailed analysis that you could probably stare at for an hour here. But it's got a little image here, shows where the storm was, the track of it as it went right over the island. And then, of course, with it going right over the island, you had different wind flows. So the worst of the wind is coming in on the east side of that hurricane. And you've got kind of the circulation pattern there in that picture. But then you've got all the mountains, right? So we showed you the mountains earlier and how the winds impact that and so forth. Well, yeah, it gets really complicated on an island like this. But they went through and looked at all the damage path and tried to map out everything. And then they noticed that there were spots in some of these red and blue areas that you see on this map that had extensive damage, and realized that there were downbursts essentially within this damage path where he believed that there were winds there reaching potentially 200 miles an hour. So they estimated there were as many as 26 microbursts or downbursts there, and winds reaching as high as 200 miles an hour. So the winds descending the island's mountains were more damaging than the upslope winds, so, which was fascinating. So you've got, again, depending on where you're at, right, this is kind of the peak of the wind, or the mountains here. And then if you've got the winds coming up this mountain, which again, you would think typically kind of a wind in that direction is going to be very damaging. But then they found as the descending winds came down and started rushing down the valleys that it was actually worse in many of those spots, which is pretty fascinating. The other thing too is that Jurassic Park was being filmed in Kauai at this time. So, you know, Kauai, if you can go to different locations where Jurassic Park was being filmed, and I just found it classic. It's like, all right, hurricane's coming, you got to evacuate, right? And then you got this quote. So Jurassic Park was filming in Kauai at the time. At first, we were going to evacuate, and then Steven was like, oh no, I've been through these things before. We're just going to stay. Category 5 hurricane, the biggest one at that point. Again, this was a Category 4, but the quote here, the biggest one at that point that had hit the United States. They continue on. Spielberg took the opportunity to actually film the hurricane as it was approaching to make sure he got some good B-roll footage. And B-roll footage meaning just, you know, some film footage there of the hurricane. In the plot, if you watch Jurassic Park, you've got this big storm, this hurricane approaching, and he wanted real footage of it. And this was perfect for him to set out and grab this footage. So there wasn't any evacuation. To them, this was an opportunity of a lifetime, which they made happen. All right, and finally, we got to talk about the Maui wildfires here back in 2023. So this is another massive event that was largely driven by the weather and the winds and the dry conditions that had developed there. And so now we've moved from, we talked a lot about the climate of the Big Island. We went clear to the east of Kauai, and now we're kind of going a little bit farther to the east there with Maui. And this is on August 8th, 2023, so coming up here on the 3-year anniversary of it, 100 deaths, the deadliest U.S. wildfire in more than a century for the U.S., and $4 to $6 billion in damage. And the fire started from wind damaged electrical lines, is what they believed. And again, I think a lot of us can remember probably a lot of these news reports. Obviously, this is very fresh compared to any of the events that we've talked about. And the one that definitely grabbed, well, I'd say the hurricane grabbed a lot of headlines too, but this one perhaps grabbed the most headlines of all of these storms. All right, so we're looking at the National Weather Service did forecast the weather event actually pretty well. If you go back and look at it, they had a red flag warning out and a high wind warning was issued. Red flag warnings meaning the potential for high fire danger and wildfires, and the high wind warning there, letting us know the high winds, of course. And so this image here from NASA shows the burned area. So here's Maui. If you're looking at the island, and again, you've got your bigger elevations here, and then right here in the wildfires, again, we're on the eastern side of that, descending down the mountains. But you can see a lot of different areas where there's some burning, but then the farther east you got, the more this really picked up. And so I found this pretty interesting by going back and looking at the wildfire. The wildfire occurred in the dry season, okay, so makes sense. The rain for the summer season technically was above normal, but they get so little rain there in the summer season. So it really is more of a wet season and dry season type of scenario there. And so now you're in the dry season. However, the wet season was really, really wet. And so you might think, well, that will keep your fire risks down. But again, now you've gone months and months and months with your typical dry weather and everything is dried out. But what happened is that that very wet season led to an abundant amount of grass growth that is essentially dry fuel when it dries out. And so there was a very large amount of that present. So the wet season before it brought near record rainfall, and it was over 9 inches above normal there. So basically 2 different graphs here, and what we're looking at is you're looking at the dry season, how much rain typically is there going through the years here. And so yeah, it was a little above normal, but again, you're only talking about a fraction of an inch there. This is the wet season before it, and here's your record, and then this is 2023. So it was the wettest that it had since 2004, and so there was a ton of moisture that led to a lot of growth that eventually ended up leading to that dry fuel for those wildfires. Here's a look at basically the setup again of Maui. So here's your West Maui Island, or West Maui Mountains here, and then the higher elevations that are off to the east. And then you can kind of see again, looking at how all this came together there. Looking at, you've got a lot of different landscapes and geography and so forth, but really the big thing that became very important here was the mountains along the weather setup. So what we're looking at here is you've got basically the overall weather setup, and this is a huge scale here. So you can actually, again, the whole chain of Hawaii is just kind of in this little circle there. So the star is where Maui is located. And then to the north there, you had a very strong area high pressure, much stronger than normal. But it's far enough north that that calmness of the high pressure wasn't settled over. I mean, we got a big area high pressure over us right now. The winds really haven't been moving. So if you're in the middle of that high pressure, it keeps calm weather around. That high pressure was very strong as far to the north. And then there was a hurricane down to the south there of Hawaii altogether. And so it's kind of unknown how much of an impact that hurricane played, because the winds directly didn't lead any issues. They were well to the south of there. But again, you did have an area lower pressure, you had higher pressure there and to the north. And so it's basically already working with the normal trade winds, and it's enhancing them quite a bit altogether, and so leading to that wind damage that ended up taking place. So now you're looking at basically the reds here are indicating some of your stronger winds, and you're right in the crosshairs of that. So the hurricane that took place, again, is down to the south, stayed to the south. Here's where all the high winds associated with it were. Here's a satellite imagery showing the hurricane, and then there's another image there. And the high pressure, again, is off to the north. So again, you're just kind of caught in between in the crosshairs there. With that said, this actually was forecast quite well with the models when it came to the wind potential that was there. So I know this looks pretty complicated here. This is looking zoomed in on Maui. This star is, again, where these wildfires ended up taking place. This is the modeling looking at how this weather would basically take place here. And the estimated maximum wind gusts there are on the screen, and for the different times as you're kind of going through. And what you see, basically, here's your mountains, here's the strong wind, and you can see how the winds, as they're coming down the mountain, they're getting stronger and stronger and stronger, and they're peaking right as it begins to move out towards the coastline there. And so that is really important, because the models were picking up on that. It was picking up on what we call essentially a mountain wave. So you had strong winds, basically normal to the terrain barrier there with a stable layer above it. These are the setups. We don't deal with it here. It's something I'm not forecasting on a daily basis, but basically you can get what is called a mountain wave that is going to go down sloping, and it allows those winds to pick up speed as it goes along, and it becomes windier and windier and windier as time goes on. And so we're looking at a lot of the upper air soundings from the different locations to kind of show the environment was right. And now we're looking at essentially your higher mountains here. Already the strong winds are coming in, and you can see how, again, the winds are peaking. And this is also showing, again, essentially the humidity there as well. So by the way, the other thing worth noting, there's not much moisture there already, but as these winds are descending down and they're speeding up, it's also drying out that air too, which is not helping the situation at all. This is a different look, and you're looking at the actual mountain itself, right? And then you get out towards the ocean, and right in here is where all those wildfires were situated. But you can kind of see this mountain wave. Here are the winds. The brighter colors are the stronger winds. You can see how it's pushing down the mountain, and then once it got down to the bottom, definitely enhanced those wildfires that were already beginning. This is a look at the wind speeds that were recorded, and right there to the south there of where all those heavy wildfires were, 58 mile per hour wind gusts. And that's essentially the peak winds. I mean, you did have a 54 mile per hour wind gust there. You still had some strong winds all the way through the island as the whole setup was windy, but the maximum was that wave was coming in just like this. Here's your mountain range, and then it just ascended right down. So it really was kind of that perfect setup there for those wildfires. And then lastly, this is a look at the radar images here. Now, the reason you do have some of this is blocked out, and this happens in these mountainous areas such as Hawaii. So that radar, that where it's situated, it's very difficult to find a good spot for the radar because it needs to be up high enough to where the mountains don't block the radar beam. But if it's up too high, it's going to miss a lot of stuff, especially as the radar beam goes out over the entire state of Hawaii, because they got to cover a ton of ground with these radar beams, and it's next to impossible to do. So as a result, you do have the radar beam that's being blocked in a couple slivers here, but you can see essentially at 7 o'clock in the morning, that smoke plume from the wildfires are being picked up, and then as you go through the day, the winds are picking up. You can see a massive amount of smoke there on the radar imagery, which is never a good sign when you see that. So, all right, that wraps up the different climates and the big weather events that I was going to talk about today, and I'll leave it up to you guys for whatever questions you've got.
This isn't so much a question, but something you might find interesting, or the rest of the people. You know, the chickens that were there,
Yeah.
you talked about. Well, they weren't a problem with overpopulating for a long time because the natives would catch them and eat them, even though it was illegal. And then they built a Costco, and people started buying those. This is what our guide told us when we were over there. They started buying those rotisserie chickens, and then the population of those colored just went crazy. I found that interesting, and I thought.
I mean, I had read before I got there, you know, there's chickens around. Okay, whatever. But getting off the plane and immediately seeing chickens running around at the airport, at Walmart, at Costco, like all these places, I'm just like, I was just blown away. Yeah, they are everywhere.
You know, living in Ohio, we're so used to west to east wind pattern, west to east. So I was surprised when you mentioned Hawaii. What are the overall winds in the Pacific? Are there larger patterns of wind, or is it localized?
Well, more localized, where you have islands, into where it's going to end up kind of stirring. You know, you start to actually look at the islands in particular. You're going to have different wind patterns, you know, through the valleys and so forth. But overall, it is more regional. I mean, if we start to actually kind of look at the globe, we could actually begin to kind of slice it between easterly and westerlies, depending on where you're at. So yes, for us, generally the weather's coming out of the west. As you go far enough to the south, it begins to be more out of the east, and so Hawaii is more in with that. Another thing, now, someone else is going to talk about this topic, I think, coming up here later in the summer at some point, but the Southwest is one of those spots that's pretty interesting because most of the time the winds are out of the west, right? But with the monsoon season that develops, you get, you know, the heat dome. This term gets thrown out there a lot of times, and you know, sometimes depending on who's talking about it or whatever, maybe it's not exactly the truth. Maybe the media will kind of blow things out of proportion a little bit. But the heat dome is a very large area of high pressure. It's an upper level ridge. It is a real thing that we talk about, and it's a dominant thing that happens in the summertime, right? So it's always present somewhere, generally. Oftentimes kind of in the middle of the country, and especially with those very hot areas, it'll drift out to the west. But it's interesting because in the summertime, as you get into right now in June, generally, sometimes the heat dome may get into the United States a little bit in the central part of the country, but most of the time, it's actually down still like in Mexico is kind of where it's kind of hanging out with that upper level ridge. As you get into later July, the average position of that begins to move towards about the Four Corners area. And so I love the monsoon storms out west. I mean, the lightning is just spectacular because you have dry air all around and you get these lightning flashes and you can see all the branches, and it's a much different look than around here. And it's flat and scenic and all that, and so it's just a much different look altogether. And we've been out there many, many times. Love going out there. But it threw me off, even as a meteorologist. First time I went out there, I'm like, wait, storms are coming out of the east. It's all normal. This is how it works. That area of high pressure gets far enough to the north that now, if you think of the clockwise flow around the high pressure, actually, depending on where the high pressure is, the winds could be out of the south, it could be out of the east, and the predominant wind direction in like Tucson, if you get that far south, is more out of like the southeast. And so what that does is it starts to draw in Gulf moisture. Now, you're still not close to the Gulf, you're still pretty far away, there's mountains in between. It's not pulling in like humidity levels like we would even have here. The dew point will get to 60 on average, and that's like a humid day. They complain about the humidity out there. It's like, oh, it's horrible. Hate monsoon season. But that moisture level is much higher than normal, where the dew point's like in the 20s or the 30s. And so that bump in the moisture is just enough now to where you get the heating over the mountains, and it starts to sparkle a lot of these little storms. But then with prevailing east wind, going east to west or more out of the southeast, pushing up towards the northwest, sometimes you get these storms that develop and little patches of cool air will go down the mountains there into the valley of Tucson. Storms will develop and then start to go up like I-10 and will go off towards the northwest. It's just bizarre because we're not used to it. And it was bizarre for me going out there and seeing it. But it just fascinates me. So it all depends on where you're at in the world and kind of where, how those winds are originating. But basically you have different bands of easterly and westerly winds predominantly depending on what latitude you're at.
All right. Well, thank you very much, Ross.
Yeah.
Thank you.
All right, thank you.